Everyone, I'm Amy, part of the ecology team on Amakhala Game Reserve. I'm going to be talking to you about how we're assessing changes in thicket vegetation structure following elephant access. It's a little bit of a follow-up to the talk my colleague Natalie gave last year about how we're using drones for long-term vegetation, so some of it might be familiar if you were here last year. Just a bit of background on Amakhala. It's a private game reserve between Gqeberha and Makhanda. It's fairly small, just under 10,000 hectares. It was established in 1999 from previous farmland. So we had cattle, sheep, goats, chicory, irrigated lands, pineapple, loads of stuff. And this historical land use has impacted our vegetation. So this is just a brief look at our vegetation types. They're not all true representations of each type because of this historical land use, but we have a bunch of different thicket types: grassland, savanna, oldlands, caroid. Then what we're doing for vegetation monitoring at the moment is we do vegetation VCAs, veld condition assessments, around every 5 years. And then we use that data along with rainfall data to do our carrying capacity on an annual basis and compare it with our stocking rates. We also do NDVI and fixed point photography from the ground since 2017, and then more recently with drones. And the objectives of this vegetation monitoring is to assess things like the success and failure of veg rehab over time, the impact of omega herbivores, species-specific impacts, so species-specific plant species, including alien invasives, and looking at things like canopy cover change over time. This presentation is going to focus on how we're using drones to try and assess the impact of elephants over time, particularly on canopy cover and deadwood. So this is just, this all came about really because we recently dropped fences between two sections and added a section of land which has given elephants access to land that they haven't been a part of or haven't had access to for hundreds of years. So it's a nice opportunity to kind of look at their impact on sort of untouched thicket. So this was the map before August 2024. So the N2 runs in the middle and cuts off these northern sections from the southern section. There is a small tunnel under the N2 here, but it's not big enough for elephants to fit through. And then there was no connectivity between these two sites. So the elephants were only on South before August 2024. Then we opened a corridor through the Bushman's River corridor, which gave them access to this section. So this is just a picture of the corridor. This was what it used to look like. It now currently has water in it, which is nice to see. And then, yeah, lots of animals have made use of it. Our elephants crossed over after just 5 days. And then you can see other animals are predators: lions, cheetah, more elusive stuff like aardvark and brown hyena. So yeah, this has allowed previously isolated populations to now intermix and increase their genetic diversity, which is great. And then in February 2025, we also added a section here, Uluvani. It's just under 400 hectares. It took the elephants a little bit longer to find this section. I think they crossed after about 6 months. But yeah, so they now have access to this whole area and they're spreading their impact over a greater area, which is good for the thicket. But now that they're utilizing these new areas, we want to see what the impact is going to be over time. So one way we're doing this is through drone aerial imagery. We're using a DJI Mavic T30 drone with a 12 megapixel camera. So we just selected sites on Carnarvondale and Uluvani. They're 1 hectare plots. This is mainly just taking into account the battery life of the drone. And we selected the sites with elephant impact in mind. So they're mostly focused on valley thicket. And then we wanted to get baseline data. So in late 2024, around the time we opened the corridor and before we incorporated Uluvani, we flew the drone. And then we are repeating it every 6 months for long-term vegetation monitoring. And we're flying at different heights: 30 meters for finer scale imagery and then 100 meters for more broad scale. For the elephant impact, we're mainly focusing on the 30-meter height. So once your drone flies and it takes hundreds of pictures, they then have to be stitched together into an orthomosaic. So yeah, this is just examples of the 100-meter and 30-meter. The stitching software for this is quite expensive, and we don't really have the resources for that. So Alistair and NMU have been helping us out with that. So thank you to them for stitching the photos for us. And then once we have the stitched photos, we obviously want to use them to assess changes in vegetation structure. So one way that we've been looking at doing this is deadtrees.earth. It's an open access dynamic database for accessing, contributing, and analyzing remote sensing based tree mortality data. So basically, you can upload your drone images or access other drone imagery already on the site. And then it has models which will automatically detect tree cover and deadwood cover. And then it allows you to go in and correct those models if there's any errors. And then you can download the outputs and use it in QGIS or other things like that. So the goal of this is to use the drone data to train models to detect tree mortality from satellite imagery. So they've already done this for a lot of Europe, which you can see here. I think Alistair is keen for them to focus on Southern Africa next, which will be exciting. And then the next step is to train the models to identify individual tree species, which will also be really useful. This is just an example of one of our sites. So this is the orthomosaic. This is the tree cover layer, deadwood cover layer, and then there's where you can edit it, and then you can download the predictions to use in QGIS or whatever you want. Back to our sites. I'm only going to show you a few of them because partly for time, but partly because we had some issues with our imagery, which means we didn't have as much usable data as we thought we did or we would have liked to have had. But yeah, so this is the only site I'm going to show in Ulavani. So yeah, you can see the image on the left is from November 2024, which was pre-elephant access, and then the image on the right is December 2025, which is a year later, but actually only 4 months post-elephant access. And visually, you can already see like a clear change. So for all of these examples, the changes you see are not necessarily all because of elephants. There's obviously other environmental factors at play, but this is just a sort of preliminary look at what we're seeing after the first year. So yeah, this is with the predictions. The dark green is the tree cover and the light green is the deadwood. So you can see for this site, it had a decrease in canopy cover from 0.75 to 0.68 hectares, and also a decrease in deadwood from 0.06 to 0.04. So yeah, this output from dead trees is a nice way to sort of quantify what you're seeing visually. And then this is another site. This is a site on CD. So this is a year post-elephant access. Like I said, we are flying every 6 months. So we do have data for June, July 2025 as well. But just to keep things simple, I'm just comparing at a year. So it's the same season. So for this site, we're seeing also a decrease in canopy cover, but not really any change in deadwood. Then just another site on CD. This is the image. This is the predictions. So here, there's no change in canopy cover. It covered the whole plot, both before and after, but there was a slight increase in deadwood. And the last site, similar thing, not too much change in canopy cover, but an increase in deadwood. So yeah, again, these are just a preliminary look at what we've seen after this first year. It does seem like the overall trend is a decrease in canopy cover and a bit of an increase in deadwood. Interestingly, this site in Ulavani was the one that had the greatest change in canopy cover, but elephants were actually only had access for the shortest amount of time, only 4 months here compared to a year with the other CD sites. But I think the reason for this is that Ulavani is a smaller section with less thicket, so I think the herd's impact was more concentrated here, and also this particular site is right next to a waterhole, so that obviously contributes to the elephant impact. But yeah, it'll be interesting to keep going with this and see what the changes are like over a longer time frame. But overall, I think it's a highly useful tool with strong analytical potential for more than just elephant impact monitoring. So you can look at drought impact, bush encroachment, spread of invasives, veg rehab monitoring. And then just getting back to elephants, I think it's really important to understand the impact of mega herbivores like elephants on the Albany thicket, especially with our fenced reserves, so where they used to move through the landscape and spread out their impact. It's now concentrated in these small reserves, so it's really important to monitor. And I think the sort of baseline data that we've got is an important first step for that. And then also just to say this drone monitoring isn't the only tool. It's not replacing other vegetation monitoring methods. It's just an extra tool. We're still going to be doing LVCAs and NDVI and all of that. Just for some lessons learned. So this is some of the outputs we had when trying to stitch our orthomosaics, which is not what you want. You can't really use this. So as you can see, this flight path is inconsistent, which is not what you want. So I think the gaps here are when there wasn't enough overlap or not consistent overlap for the photos to be stitched together. Whereas this is what you do want. You want your area to be square, and you want like the flight lines to be parallel to your square and not diagonal. If you look at this, they're diagonal, which is not what you want. And then you also just need to make sure that you fly a big enough area, an area that's bigger than your actual site, so that when the software stitches it together, the images at the edge are lost. So yeah, you need to fly a bigger site than your actual area. And then the next steps will just be to keep monitoring our canopy cover in deadwood over time. We want to monitor vegetation rehabilitation progress. So we have, like the sites I showed you for elephant impact, we have similar sites for veg rehab that we flew before we did any interventions, and then we're flying every 6 months. So that'll also be something that we want to look at. And then species-specific impact. So like I mentioned, with dead trees, maybe being able to identify different species in the future, that's something we want to look at. Specifically, woody species and invasives. So we want to look at prickly pear, aloe, speckboom, and preferred elephant forage such as cabbage tree, boer bean, common guari, and needlebush. So yeah, that's what we're going to focus on in the future. That's it. Thank you.